Good afternoon and welcome to today's Industry Week webcast, Futureproofing IIoT Systems with Modern Communication Standards, sponsored by HiveMQ. My name is Jill Jesko and I'm Executive Editor of Industry Week. And now I'd like to welcome today's speaker. Joining us today is Dominik Obermaier. Dominik is CTO and co-founder of HiveMQ. He is a member of the OASIS Technical Committee and is part of the Standardization Committee for MQTT 3.1.1 and MQTT 5. He is the author of the book, The Technical Foundations of IoT, and is a frequent speaker on IoT, MQTT, and messaging. And with that, let's get started. Dominik, the floor is yours.
Yeah, thank you so much, Jill. So hi, everybody. So thank you for joining this webinar today. So we will talk about today future-proofing IIoT and about the modern communication standards. And I will also share a lot of stories and things I've seen over the years now with our customers. Some of them are really building let's say new factories, new floors, and with really bleeding edge software and modern software. But as well, we have a lot of customers who are basically adding additional use cases, adding additional technology, and basically modernizing their stack. And so I'm super excited to share a few stories around that today. But before I start, let me quickly introduce HiveMQ, the company I co-founded and also work for. So it was founded in 2012. So we headquartered in Germany. We're a global company with basically employees in North America, all over the US, and as well as Europe. And what HiveMQ does is basically, in a nutshell, HiveMQ helps moving data in an efficient, fast, secure, and reliable manner. And our technology is used for basically modernizing shop floors, factories, but also for things like connected cars. So it's really a backbone technology. But this is not, I won't talk about HiveMQ a lot here today. What I really want to talk about is open standards and not proprietary software here. So we have more than 130 global customers, including very famous household brands. Also if you are driving a car, especially from Germany or a US car, or if you are buying a car, you will very likely have used HiveMQ technology somewhere along the journey, either while producing the car or while driving the car. But let's now dive into the topic. Let's talk about the future of manufacturing. And of course, I won't talk about Industry 4.0. I do believe most people here have dealt with the topic now for quite some time, so I won't tell you anything completely new here. But in the end, it's all about, it's important to modernize manufacturing today for competitive advantages. And in the end, it's all about improving the overall equipment efficiency, of course. So when it comes to Industry 4.0 and the future of manufacturing, there are a lot of, let's say, topics that play into that are originally not always in OT technology use, but are really more on the IT side of things. So, of course, automation, cybersecurity is a very, very, very important topic. And that is not a feature. This is really something at the core of any architecture. So we will talk about that today also, or briefly talk about that. Also, when it comes to industrial IoT, advanced analytics is really something a lot of responsible people are looking for, a lot of managers are looking for, really getting insights and real-time insights into what is happening in the production processes. Of course, smart sensors, cloud computing, and also AI machine learning is usually a big part of that. But I think what I really want to show here in the slide is it's really about IT and OT are growing together, and this is something like, and I've been at various panels now where this was discussed in length. That the IT-OT clash is something that is the reality of a lot of people. and this is something that can, like the right technology choices, can also help with that. Let's talk a bit about the business drivers. I mean, why are people even modernizing their factories, or why are they even thinking about it? So it's usually about improving the factory efficiency. And in the end, it very often boils down to measuring and increasing the overall equipment efficiency. And so this is on the one side, of course, analyzing and increasing the quality, and of course, a non-planned standstill of equipment is something that needs to be avoided at almost all costs, because this is, of course, very, very costly, and modern technologies really also need to help with that. And also it's about more flexible manufacturing. Of course, it depends a bit on the exact use case, but a lot says one. Production is something that is often very important. The reality, though, I mean, this is, I don't think I'll tell you a lot of new things right now, but the reality of people who are tasked with thinking about modernization is they're dealing with data silos, and a lot of them. So because you usually have all these systems somewhere, either in a factory, your IT systems, you have them in the cloud, and so on, and all of these systems usually are data silos. Most of the vendors that are used are really not very happy to have open standards and open interfaces to also get the data out of that. And unfortunately, this very often leads to that. And this is like, what a bowl of spaghetti might sound super nice and super tasty and yummy. You really do not want to have any spaghetti architecture in your factory or in your systems, neither in your OT systems, neither in your IT systems, and especially not when you bridge this world. And if you take a look at the reality of many managers today and people today, is you have this siloed OT systems, and there's really not a lot of interoperability. And also the reality is a lot of technologies like OPC UA and other technologies, while on the first glance they really sound like solving the problem, very often they do not. And so let's take a look what we usually see here. So on the right side of this picture, you see that the typical systems that are more traditionally seen as basically IT systems. So you have, of course, analytics. You have things like historians. Historians, for example, are for people who haven't touched the topic yet, are applications that give you an historic view of the things that are happening. So not real-time information, but really historic data. Then, of course, you have your manufacturing execution systems, your SCADA systems. And then very often you see in modern factories all kinds of applications, sometimes developed in-house and sometimes developed also by traditional vendors. And then if you switch to the left, more on the OT side of things, so there are, for example, PLCs, there are devices, and very often what we have is gateways, and wired gateways, of course, to bridge proprietary protocols. For example, OPC UA, Modbus, to name a few, and many, many others. So we also have later on the results of an industry survey I would like to share with you, where you can see what are the most used communication protocols in factories today. And of course, also gateways have usually all kinds of inputs, outputs, analog, digital, and so on. And what you do is you create this point-to-point connections from one system to another, and then you get this really bad spaghetti type of architecture where you plug together all kinds of systems, and it's almost impossible to change something, to change workflows, to change processes. And it's also very difficult sometimes to set up the new systems or even new facilities because the IT and OT operations very often is a reality of where people is a mess and sometimes really hard to either replicate or to fix. And what is also very hard is it's really difficult to analyze data across the entire system, because very often data is needed, and data is needed in other systems and sometimes even in remote locations. And also, COVID really showed that impressively. We have many customers where really remote work, even in factories, as far as it was possible, was something people were looking for. And what we've seen is, so especially also here in North America, we've seen very successful stories of also large OEMs, automotive companies, but also in other industries, where they were able to have a lot of staff remotely, and by modern architectures, they were able to also navigate through the pandemic much easier and basically without a standstill. And also, they were actually able, in COVID times, to increase the overall equipment efficiency, which I think is really great to see, and this based on modern technologies. So if you look at the goals for this kind of modernization, and after that, we will really go into the trenches and really go deep into technologies. So it's really about agile software delivery into factories, and this is something that is really amazing to see, that basically swapping over from IT, the kind of agility that people really want in their systems is coming there. And this means completely, it's not only agile thinking and methodologies, it's really also about having enabling technologies to bring technology and applications into factories in a much faster way, in a much more secure way, and especially in an iterative way. So there's not this kind of big bang project where after 2 years things get plugged together and then let's hope it works. It's really about also this kind of iterative process. And this also means if companies are able to do that, you usually also get a faster mean time to recover. Because if there is a problem, I mean, everybody who's so I have seen situations where like the company lost a lot of money because they had equipment standstill and they couldn't recover quickly. And I think that if modernization of facilities is planned, and this should also be one of the key goals. If things go wrong, one must recover extremely quickly and basically save the company money, or at least not lose as much money as you would do otherwise. And very often what we see is that companies are looking for a centralized command and control way. So what I try to say here is a visualization and also analysis of the overall manufacturing process is desired, and is even, as I said, also remotely. And last but not least, enabling all of that are consistent but also flexible software architecture is needed. So nobody wants to reinvent the wheel, but still each company has their own specialities and there's no one size fits all. And this is our good architecture should really also give you is really a great way to have a consistent and flexible software architecture. So what we saw what many companies are looking for is basically removing this spaghetti and have a very nice, very simple architecture, as we see here. So where you still have the IT systems, as we've seen, like MES systems, historians, and so on, analytics systems, and custom developed applications. And also, of course, there is, on the OT side of things, I mean, it's exactly the picture as we saw. You have, of course, still your PLCs, you have your gateways, and so on. And nobody would ever go basically and rip out all of the equipment and replace it with something new. I mean, usually what we've seen is usually there are brownfield projects. This means there is no greenfield projects. It's very seldom that there is like where people really start from scratch building that. Usually people are really just modernizing what they have, and they cannot basically replace what they have. And so an architecture is needed that enables that. And we need technology to bridge the OT-IT gap on the one side, but also allow the IT systems to communicate properly over also preferably open standards, in a way that is reliable, that is fast, and that is extremely flexible. And this is what I want to talk about today. And the thing is, what I'm showing you right now, this is nothing new. I'm showing you technology from 1999. This is very old. Of course, because the thing is, what companies are used today, and especially here in North America, there are great examples by large Fortune 500 companies who are using technology many people will know, of course, called MQTT. MQTT, as I said, is not a very new technology, but this is a technology that was there like forever. And as soon as people started connecting things more, they felt the pain point with existing web technologies, for example, or other technologies that were really not designed for very large and flexible deployments. And this is where MQTT, beginning of basically in 2012 or so, it really started like with an exponential growth curve of user adoption, started basically to get into a lot of industries. For example, if you're having a connected car today, MQTT is used for almost any vendor you can buy a car from on any market. But also for industrial IoT use cases, MQTT is used a lot for exactly enabling what I just said. But why? So MQTT has a few characteristics, and I will show you in detail how the technology works. A few characteristics that really help with basically connecting the factory. So you get a completely decoupling of the so-called clients and the broker. A broker is a piece of software that is distributing data between participants. But I have a slide on that I will show you. It implements a so-called publish-subscribe pattern. And publish-subscribe is nothing new. People who are joining here today and who are familiar with IT systems, this is nothing new. Message buses use publish-subscribe for a very long time, but not in the same way as MQTT uses that. But at its core, it's a publish-subscribe architecture, which is extremely flexible. It's extensible, and most importantly, it's reliable. Reliability is one of the key characteristics any communication protocol should have when it comes to mission-critical deployments. But how does this work? So the pub-sub pattern. So here in the middle of the slide, you see an MQTT broker. So there is, of course, HiveMQ, but MQTT is an open protocol. It's standardized. And so you can replace HiveMQ here on the slide, of course, with any MQTT broker on the market. So there are HiveMQ is used for mission-critical deployments because it adds some additional characteristics on top of other MQTT brokers, but there are also open source alternatives. So this is really not one vendor where you can use basically this architecture. It's actually many vendors can be used here, so it's not a single vendor. Of course, here we use HiveMQ as an example. So here you have the MQTT broker in the middle, and then there are data producing participants, which are called publishers. And this could be, in this example, a smart sensor, but it could be really anything. This could be a PLC. This could be an application. And this piece of software then will publish over the MQTT protocol to an MQTT broker. And the MQTT broker will deliver the same piece of data to all and any participants that are interested in this kind of data, which means they subscribed before. And it's similar to a subscription to a magazine, for example. If you, instead of going to whatever your local shop and buying your favorite newspaper, you could also get it delivered to your home. And this is the approach MQTT takes. It delivers data in a push way. It will push data to all participants who are interested in a specific piece of data. And the great thing is, the publisher of data never even knows about the subscriber of the data, and vice versa. So this is completely data-centric. And the great thing is also when it comes to security, when it comes to permission management and so on, everything can be done on the MQTT broker. So the administrators can then define what kind of data can be subscribed by which machine, by which PLC, what kind of data can be published, and so on. And you have also proper permission management, credential management, and so on. This is all basically built in here. So MQTT is used a lot in the industry. The thing is, it's not the solution for everything because it still has some issues. One of the main issues of MQTT is completely agnostic when it comes to data payload. So one could send a picture over MQTT, one could send tag information over MQTT, or you could even send firmware updates over MQTT to so-called specific topics. So, and this is a huge problem because while for IT systems like connected cars, this might be very cool because you can roll out new use cases. When it comes to modernizing your factory, you usually have a pretty, let's say, static deployment. It's not like a machine would decide to, or an application would decide to publish other data than specified. And so, yeah, this is why MQTT itself sometimes is a bit of a challenge because it's data agnostic, which again makes it very awesome for a lot of use cases. But when it comes to factories, you usually do not want data agnosticity because you want interoperability, of course, also between vendors and applications. And basically, this means a lot of the devices and the endpoints, like applications, they use different topics, payloads, and data structures, and it all boils down to not being interoperable without a lot of effort. Because the thing is, if you want to buy an equipment, for example, from Rockwell, you also want to let it work with your Siemens equipment and PLCs. So, and this is where the people who invented also MQTT stepped up and basically created something that is called MQTT Sparkplug. Sparkplug is an open, completely free to use, open and open source protocol on top of MQTT that defines topic namespaces, data models and data structures, extensible payload where you can also have any additions while still being interoperable, and it also defines what is called MQTT state management. And this is basically what this does is it makes MQTT very suitable for manufacturing processes and fits very well into the concepts used by SCADA systems. Of course, so we have, for example, but before I go into that, we have customers who are using MQTT exclusively without Sparkplug. This means they are defining their own payload format. They're defining that. These are usually very large companies, Fortune 500 companies, who are also investing heavily and have their own teams. For our customers who do not have dedicated teams that are dealing with architecture and with data languages and so on, Sparkplug is usually really the best choice because Sparkplug allows for plug and play interoperability. And this is what it's all about. It's plug and play interoperability between IIoT devices and IIoT applications. So basically, Sparkplug is here to bridge the IT and OT gap. And it's really, so if you're using a Sparkplug-enabled equipment, PLCs, and software, you're really just pointing them to an MQTT broker, and it just works out of the box. It has things like auto discovery. You can automatically, all tags get sent directly. You can browse through everything. And yeah, this is really just amazing to see. So it has some concepts called also continuous session awareness. This is very, very relevant because very often a lot of data is produced. And this is also the repo by exception plays into that. A lot of data is produced usually in factories. And very often, tag data does not change. So there is this pull approach used today for many protocols where basically every whatever millisecond or 10 milliseconds or even less or more, specific tags are read and then basically distributed to a system dealing with that. And very often things do not change. And this is very costly from a bandwidth perspective, and this also limits the scalability of the use case. And MQTT Sparkplug works the way it has built in a report by exception. This means data is only carried to other systems if they have changed. And systems can then also rediscover with MQTT Sparkplug the latest value that has been produced also. And this really saves up to, so there are companies that save up to 90–95% of data volume. just using things like Sparkplug and MQTT. And the thing is, one could say, yeah, we really don't care about that. We have pretty good bandwidth in the factory. Yes, this is true. The thing is, what we see a lot is that cloud enters the play. This means a lot of the data that is used in factories is now required to be in the cloud for machine learning purposes very often. For example, predictive maintenance use cases. So if an example would be, we have a customer, they have multiple sites around the globe, and they want to really get also insights from the same equipment that is used around the globe, and feed all of the factory data into a big data lake where they can do machine learning on top of that, and then basically have better quality predictive maintenance processes, because they can also basically simulate things, like they can compare against other sites and so on. And so really having the data in the cloud really enables them to do a lot of things they couldn't do before. But you just cannot point, if you're producing so much data, you just can't point it to the cloud. It's so expensive, and there's not a real value if you're producing data that hasn't changed. And Sparkplug really only produces data if it changed. It has an interoperable and consistent data format, and it has auto discovery. So if you have a new application, a new equipment, you just basically point it to your MQTT broker here in the middle, and then it works out of the box. And so an MQTT Sparkplug architecture looks like that. This means there is, as I said, an MQTT broker in the middle that is bridging all the application and delivering the data where it needs to be. There are, in Sparkplug, they're called MQTT application nodes. These are software nodes that can communicate over Sparkplug, like MES systems, historians, analytics applications, and other applications custom developed. And you just point them to the MQTT broker, and then, yeah, you have an out-of-the-box experience usually. There's really not a lot of configuration that you need to do. Then there are the so-called EON nodes, or edge of network nodes, usually also called edge nodes by Sparkplug architects. These are usually the gateways, but also PLCs. There are many PLCs on the market that have direct Sparkplug support, and you can just point them to the URL of the MQTT broker, and then they're connected, producing data, and then you have it usually in your central SCADA system, or also IIoT host called in Sparkplug language. And there are multiple vendors there that support that out of the box, which you also just point your SCADA system to the MQTT broker, and then you get instant browsability and discovery of all nodes, of all applications, and of everything that is happening. And of course, you get this real-time updates, or this real-time in terms of as fast as possible, usually sub 10 milliseconds updates on your SCADA host to see what's happening. So I now like to go a bit more into the different things I just mentioned. So usually what you have is a so-called SCADA or IIoT host. This is an application that is responsible for monitoring and controlling the MQTT edge of network nodes, which could be gateways, which could be PLCs, and so on. This system is there for maintaining continuous session state awareness of all the participants, like machines, devices, gateways, sensors, applications. So this is really the truth of what's in a Sparkplug system is there. And it basically collects all the data from the MQTT broker. But, and this is different to many other approaches of architecture, the system is not responsible for connecting directly to the devices. So it just connects to the MQTT broker, and the devices, like the things, the edge of network nodes, as well as the applications are completely decoupled. So they usually don't even know about the IIoT host in the system. So then the second part, which I mentioned, are the so-called edge of network nodes. So edge of network nodes, they provide a physical and logical gateway function and bridging devices that do not implement Sparkplug. So very often what we see is there are OPC UA enabled devices, and then a gateway is used to basically take bridge OPC UA to a pure play MQTT world, and then bridges the data to Sparkplug and to the MQTT broker. So edge of network node also manages the state and the session of the connected sensors. So if you plug in to your gateway a specific smart sensor, for example, then this edge of network node in Sparkplug will also take care about the life cycle. So it will report if the sensor is online or offline, and depending on the protocol that is bridged here, this might differ, because if you bridge OPC UA or Modbus or even some proprietary standards, then I mean this really depends on the gateway that is used here. But it will report if something is offline, if a machine is offline, if a PLC is having troubles and so on, it will report it back to the basically Sparkplug system. And then there are devices that, I mean, this is in Sparkplug, they're called devices or sensors. This is really what it's about when in manufacturing, right? This are really the assets. These are the key endpoint in any industrial automation system. So the devices and sensors, they connect over, as I said, over edge of network node if they're not Sparkplug enabled directly, as some of them are, and then basically this is bridged to a Sparkplug world. And then there's also another category I'd like to mention. This is called an MQTT application node. So this is basically any application you can buy. This can be historians, but also if your company develops their own software, you can just use MQTT, and you can get data, you can produce data, but this is not a SCADA IIoT host. So usually you see here MES systems or analytic systems as well as historians. These are the traditional MQTT application nodes you would see in many deployments. And then last but not least, the last one is really an MQTT broker in the middle. The MQTT broker is really the heart of the architecture because it will distribute the data. And you can use any MQTT broker you want. There's a few requirements. Number one, you need 100% compliant MQTT version 3.11. So most or many commercial vendors and open source products have that, or projects provide that. One thing of awareness, if your cloud providers, on the one side, you usually do not want to have your central broker for your factory in the cloud. This is number one. You really want to have it near your equipment and then bridge data to the cloud. This is also, of course, possible with MQTT. So you can have a local MQTT broker that is pushing data to the cloud. So yeah, this is a very classic. But please do not use a cloud-hosted broker for your production processes, because if you have any internet connectivity issue, you really do not want to have equipment stand still or similar, just because the cloud is not available. And even then, also Microsoft as well as AWS, they do not provide, as well as Google actually, they do not provide a compliant MQTT broker. They implement a subset of MQTT, a very specific one, but you cannot use it with Sparkplug, and actually this cannot be used for, So for production purposes, I really would go for a dedicated MQTT broker. You need features like retain messages, which the cloud do not support, and especially Microsoft, and last will and testament and quality of service. I will not go into that right now. These are really nitty-gritties of the MQTT protocol, but this is something that is really required. So be aware when choosing an MQTT broker. And the thing is, there's really one problem I'd like to point out also with MQTT. As you see here, if the MQTT broker is having any issues, then this might be really a problem from a production process perspective. So what is really used, like in reality, by companies who rely on manufacturing? They use a commercial or professional MQTT platform. In our case, of course, it's HiveMQ. So there's also a Chinese vendor out there that provides something similar. but so let's say in the European and American market, we are pretty dominant there currently when it comes to pure play MQTT platforms. So because we provide high availability, this means there is a so-called clustered approach. That means even if, let's say, one server would go down or even multiple, there is always availability guaranteed, and there is no problem there if, let's say, there are server problems or connectivity problems because of the redundancy and the high availability built into that. So it's usually also called broker clusters. It's 100% MQTT compliant. So yeah, MQTT version 5 as well as 3, of course. HiveMQ is really scales from let's say a single proof of concept to really production data where multiple gigabytes of data are carried around every second to the cloud, in the factory, and so on. And it also has a horizontal scalability approach. That means if more scalability is needed, additional server instances can be added as required. And I mean, HiveMQ is used in factories as well as in the cloud and powering, let's say, production processes of Fortune 500 companies, but also as well as in the cloud, connected car platforms with literally 5 million plus connected cars that are distributing data around the world. So, so this means HiveMQ can be installed on premises, on things like Kubernetes, on clouds, on like actual server hardware, bare metal hardware. From a software perspective, the software doesn't really care where you install it. It has observability features built in. This means you can dig very detailed into what's happening, what is with the data producers happening, and so on. And there are actually, I think, more than 2,000 data points and monitoring points you can look at and drill deep for debugging purposes, but also for general monitoring. And we also provide additional tools for troubleshooting and so on. So if, for example, a machine doesn't work as expected because it doesn't produce data, HiveMQ can also be used as a diagnostics tool for basically debugging that specific machine. So it integrates with enterprise security requirements. This is basically the bread and butter business we do. So security, as I said, is not a feature; it's an architectural decision. So HiveMQ integrates with basically all the kind of key management systems, databases, and commercial systems that are used on the shop floor, but as well as on the cloud. And yeah, it integrates really nicely with OT and IT systems. So to sum that up, so the Sparkplug architecture, to bring that to attention again, this is really the Sparkplug architecture. It's extremely simple. You get rid of the spaghetti code. If you think like this, okay, you have never heard of that, so you're not quite sure about it. There are great case studies, for example, from Chevron online, and they tell also how when they moved to Sparkplug, how much basically money they saved and how they could basically connect their sites around the world. Yeah, with this technology. So there are multiple case studies online on that. But before I let you go, and before we go to the Q&A, I'd like to share an industry report that was recently conducted when it comes to open standards. So, and this might be very interesting, and let's talk about that right now. So, so IIoT World did a survey in October 2021, so pretty recently. And people asked, like, which of the following protocols do you use today to connect your equipment? One thing said here, the audience here, so we have the report also. Please reach out to us if you want to read the full report. We have it available, and we're happy to share the report with you folks. So reach out afterwards with a slide on how you can contact us and also contact me if you want to get your hands on that. So this is super interesting because we have here, there are CEO people, there are head of production people there are also software developers in there. So a very, let's say, interesting mix of the audience with a focus on people responsible for ensuring manufacturing processes are working as expected. So of course, Modbus is something like, of course, it is very dominant. But also, of course, OPC UA is used a lot. Then some people also have KNX, which of course is more on the home automation side. BACnet, of course, another Profinet. And then there are some others like MT Connect, for example. And then there are other protocols, of course. What is interesting, though, is 50% of all people responding also added that MQTT is used to connect their equipment today. What's also interesting that Sparkplug, what we talk about today, only 5% are using right now. This also shows, of course, that is a very, let's say, recent technology just being specified by the Eclipse Foundation as an open protocol on top of MQTT. But MQTT as technology is used a lot by the industry. And of course, you also see HTTP, which is very often used, of course, for web interface access and so on of specific tools. A second thing I want to share with you is the question, which of the following protocols do you consider strategic to fulfill your IoT strategy, IIoT strategy? 50% of participants said MQTT is one of the protocols that they think is strategic. And again, this is something not software developers said. This is something CEOs of companies said. This is something also technology leaders said, and the architects said here. And while only 5% use Sparkplug right now, 1/3 of all the respondents, almost 1/3 of the respondents, said they consider MQTT Sparkplug strategic. And OPC UA, 35% consider it strategic, and as we've seen, of course, almost the same amount of people already use it. So I think this very much also shows that MQTT Sparkplug is something a lot of people are really considering using right now. And MQTT, as you see, is already used a lot. And Sparkplug just makes MQTT better for manufacturing purposes. A very quick look on what is the Sparkplug ecosystem. And actually, this is much larger than that. But just to have a few companies out there, and there are also others like coming very soon, which I'm aware of, like very large brands, PLC vendors, and so on. So if you have a look, here's a link on HiveMQ.com. There is also we have a Sparkplug solution page where you can look at that. This is very updated, like weekly on the vendors, where you can basically buy equipment, what they're using, and also where we collect what can be used here to implement Sparkplug. And again, this is just the tip of the iceberg you're seeing here on this slide. Okay, so now we're like almost finished with the official part here. Just one thing, if you want to look at the next steps. So if you want to learn more about the technology, like how does Sparkplug actually work? There's a copy of the Sparkplug Essentials ebook available on our website. This will also be sent out afterwards for people who want to get their hands on that. And if you want to learn really more about the details of Sparkplug and want to have a demo and really see that, also like how we do it with PLCs and like actual demos, you can book a demo with us. And if you're not ready to book a demo, also feel free to go on YouTube, Google for Sparkplug HiveMQ. There's also a video series I shot where I basically am describing and walking through about the technical details of Sparkplug, not just on a very high level overview as we did today, but on a very thing. Okay, so also there are other resources. There will be, you get your hands on this presentation, so you can also look at that afterwards. If you're new to MQTT, just Google MQTT Essentials or go directly to HiveMQ.com with beginner's material. And yeah, last but not least, then also feel free to reach out to me after this webinar. I'm on LinkedIn, I'm on Twitter, Google my name, Dominik Obermaier. So it should be pretty easy to find. And having that said, I would now like to open the floor for conversations and Q&A, and would like to hand over to Jill.
Okay, thank you, Dominik, for that great presentation. We have already received a couple of questions, so we are going to jump into that. However, before we do, I would like to remind our audience, please take a moment to complete the feedback form that will appear on your screen at the end of the webinar. And with that, the first question that we have today, Dominik, is Sparkplug like OPC UA with a MQTT wrapper?
No, actually, OPC UA has an MQTT almost wrapper. The thing is, OPC is on the other end of the spectrum than Sparkplug when it comes to complexity. Like if you look at the specification and all the specifications of OPC UA, last time I checked, it was more than 6,000 pages. If you put together all of the specifications, the Sparkplug specifications is I think less than 100 pages. I think it's 70 or so, and the MQTT specification is also around 50 to 70 pages. So just to give you an example of that, it really, I mean, a lot of the, let's say, bloat OPC UA brings, and it's not always needed, is not part of MQTT Sparkplug. MQTT Sparkplug, the biggest difference, and this is something I was completely blown away when I talked to some Sparkplug users, and they told me that they could literally do a proof of concept, and their engineers were able to do that in an afternoon, and they had to show something to their boss in less than a week. A complete end-to-end integration of equipment to cloud monitoring systems and so on. And with OPC UA, this is not very often the case because, I mean, a Sparkplug is not really replacing OPC UA. Sparkplug is really there to bridge the OT-IT gap in a very efficient and very easy manner, and it also is used to connect factories to the cloud. And I know there are additions to OPC UA which also theoretically would allow that. There are some success stories out there, I believe, but I know many companies are struggling with that. Sparkplug is really there. It's extremely simple. And I would challenge everybody who has an engineer in their title to try it out. And I would expect that you would need less than a day to grasp the concepts, learn everything about the specification, and get a proof of concept going. Where you have real devices connected to a real broker, to a real application using it.
Okay, thank you. We are going to jump right to our next question, which is, can I use HiveMQ MQTT broker in the cloud?
Yes, you can. As I mentioned in the beginning or in the middle of the presentation, MQTT, as also HiveMQ, can be used in the cloud or on premises. What we usually recommend is to have on-premises broker that is in the same local network. And also, I mean, in details, there will also be multiple network zones, for example, but like locally, and then connect basically the MQTT broker to a cloud broker. This is possible with the MQTT technology. So you have this kind of federation concept. This means in the cloud, you can use that. And I mean, if you want to try out MQTT and say, yeah, you really don't want to download a broker and deal with that, on our HiveMQ web page, we also have our own cloud offering that gives you a 100% standards compliant MQTT broker for the cloud, which is free to use for 100 devices. So if you don't want to set up your own broker, you can use that. You can find it under hivemq.cloud, or just Google HiveMQ Cloud, and you will very likely find that. You can register, no credit card required, and you have an MQTT broker for 100 devices, and no strings attached also to try that. Of course, for production, I really would not use the free offering, of course. But yeah, long story short, you can have it in the cloud, host it yourself in your cloud on Azure, on AWS, on your on-premises data center. But we also recommend for manufacturing to have another MQTT broker locally, so you are not reliant on any cloud connection.
Okay, thank you, Dominik. We are going to move into our next question, which is this. Could a decoupled architecture, IIoT, be more reliable and more safe when it comes to cybersecurity and data protection. Could you comment on that, please?
Yes, and this is something the centralized approach really brings a lot of benefits there, because one can roll out security policies in a central place, and it can be changed immediately. It can be updated immediately, and it will immediately take effect. So, and also, this is a detail of MQTT. I haven't talked about this yet. With MQTT, the client applications always communication. This means you don't need to expose your equipment or your PLCs and so on, so anybody can connect because the equipment connects to the broker. This means there's really no attack vector also to the machines, to the PLCs, and to the applications, because the MQTT broker will never ever initiate a communication with the devices. The devices always start the communication. And then you have a standing, technically speaking, a standing secure connection over TCP and over TLS or SSL, and an encrypted channel for encrypted communication. And this is basically what I just said is out of the box, nothing to do here. What is required for professional deployments are policies, like you want to add a new application, so you're rolling out security credentials to the application they can use. Could either be a certificate, or it can be like simple username and password combinations, or some more advanced things like OAuth. But I actually have also a presentation on that when it just comes to security. What if you want to harden that in production? But usually this is really it. And it gets more interesting when you also put in cloud communication into the mix, because you never ever want to have somebody initiate communication from the cloud to your factory, no matter what, even if it's secure, because the thing is you can also do so-called denial of service attacks if you would allow that. With MQTT, this is not possible. The broker locally can only initiate with the cloud to a trusted endpoint, and then you can move the data here. So from a security perspective, what we've seen, actually having a decentralized approach makes it much easier. And again, the kind of spaghetti bowl I showed in the beginning makes it so hard to secure every one of these point-to-point lines. With a centralized approach, you're in control. And also, a broker like HiveMQ will alert you if something bad happens. This is also something, the benefit of a professional broker, a commercial broker. This is something like if there are any breaches or any problems, the MQTT broker will basically ping you and tell you about that.
Okay, thank you very much. And our next question is, what types of industries are currently using Sparkplug?
This is a very good question. So, I mean, many industries. So we have customers from pharmaceutical, oil and gas, to traditional manufacturing, automotive manufacturing. It seems like Sparkplug really has a lot of traction when it comes to oil and gas and manufacturing. This is really what we observe most. But frankly, there are so many industries we've never thought that Sparkplug might really help here. What we discovered recently. But yeah, I would say oil and gas, manufacturing, and then there are a lot of other interesting things coming up. And some people even use Sparkplug for their cloud communication, for putting on water sensors and putting them to the cloud. But this is a very unorthodox case. So I would say manufacturing and oil and gas.
Okay, thank you. And it looks like we have time for one final question. And it is this. I'm very interested in using Sparkplug. However, I'm struggling with comparing the benefits of Sparkplug, which is built on MQTT 3.1.1, to the drawbacks of not using MQTT 5.
That's a good question. So to give the audience a bit of background, MQTT version 3 was released in 2014. MQTT version 5 was released in 2018. And Sparkplug, the current version, is built upon MQTT version 3. So, and we get this question very often, like, should people start with MQTT version 5 directly or use Sparkplug, which still use the old one? I would say, like always in life, it depends. So if you are confident that you do not need Sparkplug, I would start with MQTT version 5, and then you can still carry Sparkplug payload over that. There's technically nothing that restricts you. If you want to have plug-and-play interoperability, I really would go to Sparkplug, which uses MQTT version 3, and it uses that version because of the interoperability. So this is why still the older version is used. MQTT version 5 has a lot of very interesting new features, but this is not needed for Sparkplug. This is really needed by advanced users of MQTT. So I would say, to answer the question, go for Sparkplug if plug-and-play interoperability is important for you. If flexibility is more important for you than plug-and-play interoperability, I would go for MQTT version 5, because you can then always still bring in Sparkplug. And the thing is, if you're using HiveMQ, for example, we have a compatibility layer. So you can also have MQTT version 5 and Sparkplug and MQTT version 3. In the same deployment, we have interoperability between these. So this means you can also have an application with MQTT version 5 and have equipment with MQTT version 3 based on Sparkplug and get this kind of interoperability. But this is something, again, usually you need a commercial MQTT product like HiveMQ for. If you want to do that, if you want to make it simple, then just pick one technology.
Okay, we have reached the top of the hour. So excellent presentation. And I would like to thank our speaker, Dominik Obermaier. I'd like to thank our sponsor, HiveMQ. I'd like to thank our audience for their kind attention and their questions. And finally, on behalf of Industry Week, have a great, productive remainder of your day.
Thank you, folks. See ya.